Good morning, students. So, for electronics lab, myself and William Christopher sir will be your in charges, and the lab instructor will be Ajay Kumar from AZE department. So, any clarifications you can approach us. Here we are going to see about PN junction diode and Zener diode. So, PN junction diode. The circuit is given. If you see the circuit, to measure the ammeter, to measure the current, I'm having the ammeter. To measure the voltage, I'm having the voltmeter. To supply the circuit, I'm having the RPS and a resistor to limit the inrush of the current to protect the devices. So if you see the apparatus required, obviously I need a diode. I've written the diode. An ammeter ranges from 0 to 30 and voltmeter ranges from 0 to 1. A resistor, RPS, a breadboard and connecting wires. So these are the apparatus required which you can write from the circuit itself. Now I'm having the breadboard and the components. Let me face my resistor and the diode. Okay. So after pasting your resistor and the diode, I'm going to connect it. So from positive of the supply it is connected to the resistor, positive of the ammeter to the resistor, and the negative of the ammeter to the anode, and the negative of the supply to the cathode. So the whole loop is completed. The only thing is left out is the voltmeter connection. So from the voltmeter I'm going to give it to the diode, and negative of the voltmeter is going to give it to the cathode. So this is the breadboard connection. Okay, so after connecting this, I just wanted to show you the virtual connection here. So from the positive of the supply, I'm going to give it to the resistor, then to the ammeter, ammeter to the anode, anode to cathode to negative, it is grounded, and then you connect the voltmeter. Now you check the connection. The connection is correct. So what I'll do is, I'll set my resistance first to 1000 ohms, and then choose the diode. We are using 194007. I have chosen it. Then you vary the voltage, tabulate the reading, vary the voltage, tabulate the reading, vary the voltage, tabulate it. So same thing, you do it till you have a set of readings. Okay. So I'm having around 8 set of readings. Now what I'll do, I'll stop with this. I plot it and see my. So this is the characteristics of your PN junction diode, and this tells you that it is 0.536 cut-in voltage. Okay. So this is regarding your characteristics of your PN junction diode. Okay. So let me move on to the next part. Now, if I'm telling you we are going to connect a reverse bias, just connect your positive with the cathode and negative with the anode. Okay. So here also I'm using ammeter 0 to 500 microamperes. Okay. So now don't disturb the connection, only change the ammeter and then the diode will be reversed. So such that I am just changing the diode. The cathode will be connected to the positive and the anode will be connected to the negative. So the same thing we will see. So here the reverse bias, I am connecting the positive. I have changed the diode. You can see that ammeter to the cathode and the negative anode to the negative supply. Then all the connections will be connected. Check the connection. Yeah, it's correct. So choose the diode. Then you set the resistance as 1000, more or nearer to 1000. You vary the voltage, plot it, vary it, plot it. So till some point it is 0. After some value it is going to break down, which is uncontrollable. You can see that. Okay. It is uncontrollable breakdown, which is called as avalanche effect. So I'll plot it. You can see the avalanche effect now. It is uncontrollable. From minus 2.69 volt, it is breakdown and it is uncontrollable. So this is regarding your reverse bias. Okay. The same thing will be demonstrated to you in the video now.
Characteristic of PN junction diode. The diode is polarity anode and cathode. This silver ring is on the cathode, this side is anode. Diode number is 194007. Another side is cathode, same for Zener diode. This black ring side is cathode, this side is anode. We are using 1 milliammeter 0 to 30 milliamps, 1 voltmeter 0 to 1 volt. Ammeter is connected, the circuit diagram is series, voltmeter connected, circuit diagram is parallel. Connection are made as for the circuit diagram. Switch on the supply, RPS. RPS means regulator power supply. Using the voltage, take corresponding reading up to 0.5 volt. Voltage is varying. The voltage is varying. Corresponding current will be measured in the milliamps. Reverse bias. Change the diode in reverse means cathode to anode. Ammeter changed in 0 to 500 microamps. Switch on the supply. Take corresponding reading varying the voltage.
Now you take down the readings, plot it in the graph, and find out the necessary values. Okay, students? So next we will move on to Zener diode. Zener diode, instead of PN diode, I am using a Zener diode. And also voltmeter, I need a 0 to 1 and 0 to 10. The only difference is Zener diode is going to conduct in the reverse bias. There is no breakdown at all. Okay, this breakdown is called as a Zener breakdown. So let me connect it in my breadboard. So I have a Zener diode. The orange one is the Zener diode. The black color line will be the cathode. The other end will be the anode. So from the positive of the supply, I'm going to give it to the resistor. From the ammeter positive resistor, meter negative to the anode, and negative to your RPS. And then voltmeter is connected across the Zener diode. So this is your breadboard connection. If I am saying reverse bias, is nothing but I have to change my voltmeter to 0 to 10, change the Zener diode position. So here I'm going to change 0 to 10. The Zener diode position is changed like this. Okay. So instead of your diode, I'm changing the position to cathode will be supplied with the positive supply and anode will be with the negative supply. We will see the same thing in the coming video.
Here is stop the Zener junction diode. Connection are made as per the circuit diagram. Switch on the supply. Varying the voltage, take corresponding reading. In reverse bias, change the diode in reverse, means cathode to on. Switch off the supply. Meter changed. Voltmeter is changed. 0 to 10 volt. Switch on the supply, varying the voltage corresponding reading.
Tablet the readings. Okay, note down and tablet it, and plot the graph. Submit the same. Okay, thank you, students.